Assalamualaikum and good day to all of you. So today we will continue our lecture on the load calculation analysis. So basically this is the second one. The previous one on the previous lecture is regarding on the estimation of load using the cooling load check figures. So that one is quite simple compared to this one is we are heading forward for the quite complex one, but this is I can say that it's also a simple compared to other load calculation analysis, which is using software, for example. So now we are using a manual calculation for the load calculation analysis and estimated cooling load. So please beware in mind that this is the estimated of cooling load. So basically we are using the ASHRAE also on the guideline for the calculation. So I've uploaded the slide for you guys and the cooling load list or cooling load form in your resource folder. So please use this align with the slide and this video to make sure you more understand and you are doing it accordingly. So, usually this method will apply to the service technician or the service engineer to know the concept of cooling load calculation that necessary for service work, for example. And we want to check it with the actual one and the prediction one. Somehow it is the factor that we use in this calculation will be different with different district, different area, and different altitude, but somehow this is only the guideline before we can obtain the actual cooling load value, which is using the software. So some reminder of you for you guys. So this calculation is made for finding the approximate. So just now I've told you before, it is we can only estimate and we can find the approximate cooling load calculation because we doesn't know the exact value of the cooling load. Usually the exact value we will be using the software to know the exact value. So it is not recommended to use in case of the necessity, exact necessity. So usually if you want to find a chiller cooling load, for example, chiller power, chiller, how much the chiller ton refrigerant, so you have to find a very exact calculation on cooling load for that purpose. So it also used to calculate rough cooling load for residential aircon, for example, for your split unit or package unit or ceiling cassette unit for your house. So the formula will be the cooling load is equal to cooling load per floor area, and then the floor area in meter square. So this calculation will be obtaining the cooling load for package aircon. So in case we are using for the residential aircon for the our house, for example, for split unit, we have to multiply it to 0.7. So it is I will explain later when we know the formula of that. The data that we have here is accordingly to the temperature condition of outdoor 33 degrees Celsius. So it is quite now this is outdoor ambient temperature is quite high, but somehow we are using the outdoor temperature. Ambient temperature is for 33 degrees Celsius and 27 degrees Celsius for where the well bulb, and the indoor temperature condition is about 26 degrees Celsius, and the well bulb temperature for indoor condition is 19.5 degrees Celsius. So the standard cooling load, in order to decide the standard cooling load for outdoor air for 1 meter cube in volume, so we are using 8 kilocalorie of heat capacity uh, in this calculation and this estimation. So now please look into your formula and appendix that I've uploaded, and please look into page 8, 9, 10, and 11. So page 9, 10, and 11 will be used in this lecture, but somehow the value of this table uh, I've uploaded into I've converted into the Microsoft PowerPoint that I will be used here. Now it is the same, and we are using this for our cooling load calculation here. So now we have the wall that face to the outdoor, and we have the light construction, medium construction, and heavy construction. And if you are looking into the coefficient of B, we have the north, east, southwest, northeast, southeast, southwest, and northwest. So the value of coefficient B then will be transferred into here in your coding dot form. So we in the item of wall face to the outdoor will be write it here, and will be measure the area of that specific area, and then the coefficient of B will be put here, and then the C will be reflect to the area times B, our coefficient, and then the coefficient of F usually will be given, and then depend, but somehow for window uh, we are using and referring to um, the table, and then the load is equal to F times C. So C is the value that we get from the A times B. So now let's go to the example. Before that, let me go through to the coefficient of cooling load that we have here. Now we have the wall face to the outdoor, then we have the roof. In case of we have roof, it is light construction, medium construction, or heavy construction. And then we have the window glass. So window glass we have here is about 5 type of window glass, from the normal glass type until the glass block, and then the shady window, in case the it is given there of shady window, and then in case of it is sunny window, it still depend on the orientation of the location of the building. And then please beware, we are only looking on the coefficient of B here, and then next one will be the coefficient of blind that attached to the window, and then we have the partition of the room. So in case of the rooms are not cold here, so now we have the glass or wooden plate and others, so we are looking on into the coefficient of B also. Now we have the ceiling and floor. In case of the room is not, it is in the middle of the building. For example, we have the 3-story building, so the second floor will be in the middle of the floor. So we doesn't have any roof, right? So we have only ceiling and the floor. So floor, we have the material only concrete, linoleum or carpet placed on the floor. Then we have the grass mat, and then floor attached to the ground directly. So usually this one will be referred to the first floor or ground floor. Then we will refer to the coefficient of B, and then we have the invasion of outdoor air. So it is only standard or many entrances are in the room, so that one will be reflect to the 2 or more walls are face to the outdoor. So if your room is have many entrance, for example two entrance, or you have 2 or more walls that face to the outdoor, so we have to select the coefficient of B here, but it is 8 for the standard, and 8 times you can choose either 1.5 to 2, so you can get whatever the result from there. So we have also the area correction of outdoor air. So from the cooling load form, you can see we have the wall face to the outdoor, roof, window glass, partition, ceiling, floor, outdoor air here. This is the area correction for outdoor temperature. So invasion of outdoor air, so the room volume, you have to get how much the room volume there. Then the area coefficient, either it is 1.1 or 1.2, and then we have the occupants here, how many person is there in that area. So and then next one, the light electric watt, this depend on how much of the electrical watt that are available in that room. So actually, if we are having face-to-face class, we will be using the rule of time putting from here like this, but I've converted into the Microsoft Excel for your it is easy for you guys to calculate the calculation in using Excel. So let us begin with the example afterwards. So now we begin with the example here. So this is the example. We have to find the cooling load of an office based on the following condition. So usually the specification of construction of the building or a space will be given in the question in case of it is appear in your midterm or your final exam, and of course this will be appear in your final exam. So for example, the specification of the construction for the building. So usually the specification of construction in uh, actual case, so usually the spec will be given by the architect, for example, or the consultant. So in this exercise for our building, it is it is a 5-story building, and then the outside wall will be referred to the wall that fits to the outdoor. We have the medium construction, which is the concrete block 150 millimeter thickness. And then with the window glass, we have the normal 6 millimeter thickness with blind. Um, all of the specification you have to properly read to make sure you doesn't miss the spec. And then the floor is concrete with linoleum, and then the ceiling is only concrete, and then the light is fluorescent light, which is they have about 20 light here, the quantity, and then the 40 watts times 20 is equal to 800 watt, and then the person that are in the office is 15 uh, person that are using a light working work, and then the area is we are using the standard temperature area. So the adjoint upper and lower room are not cool. That means we calculate it and refer to the table that we have is which is the adjoint upper and lower room are not cool. So this is the example of we have here. So as you can see here, there is about 1, 2, 3, 4, 5, 6 window that have blind, and then we have also window that are attached here to the passage, and then we have two door here that are enter to the room. So we want to calculate only the load that are specifically to the office, not this side or this side. So in that room, so the area of the room is 7.5 times 18 meter, and then the first that you have to look into is the orientation of north here. So this is the north area is to the upper side of the uh, room. So now the north orientation is on your top of the room. So we have here north, south, west to the left hand side, and the north, south, west, east on your right hand side. So this will be the north, south, west, and east. So this side will be the northwest, southwest, northeast, and southeast here. So now from the cooling load, you can put it, for example, name of constructor, which is, for example, I put Ame, and then the address is, for example, Melaka. Name of the room is, for example, office, and then the floor, which is the area, this second floor, and then the person in charge, maybe Ame also. The room area, how much did we get here? It is the room area is 7.5 times 18 meter. So we got about 135. And then how we can get the room volume? 135, and then they have the ceiling height there. Ceiling height will be referred to the height from the floor to the ceiling. 135 times 3. So we can get 405 meter cube. So this is meter square, so this is meter cube. All right, now heading to the wall that face to the outdoor. So as you can see here, there is only two side wall that face to the outdoor, because this side will be the next room, which is not facing to the outdoor. Facing to the outdoor is referred to the wall that are facing to the sun directly, and then this side also will be referred to the corridor. So this side and this side will be not face to the outdoor, so only this side and this side will face to the outdoor. So there is two wall that face to the outdoor here. So now either one you can choose, either you can start from the west side or from the south side. So this is the west, we can say it is from west. Usually I like to write like this. So uh, the west equal to what is the area of the wall, 7.5 times what is the ceiling height, is 3 meter. So somehow it is the area of the wall only. So now we will 7.5 times 3, and then we will have to minus it to the wall. Here they have window, two types of window here, which is 1.6 times 1.6 times 2.5, and then we have to times 2, because they have uh, two windows there. So this is on the west of the wall, and then the next one we have on the south area. So south is equal to 18 meter, 18 times what is the ceiling height, is 3, and then whatever they have in the wall that we have to measure, because we want to calculate only the wall, not on the window or the glass or door, because that one will be measured and calculated on the window glass here, and then the partition or shielding here. So now 18 times 3, and then we have to minus how many window they have, 1.6 times 2.5, and then we have to times into 4, because they have about 4 wall here. So the result from here you have to put in here. So usually I like to full or fill on the item first before I find into the area and the coefficient of BC, but it still depend on you guys, either you want to complete one by one or you want to complete the item first. Now we have complete the items on the wall face to the outdoor. We will calculate the area afterwards, but now let we fulfill the items first. For the roof, it is on the second floor, so I don't think we will put any items here. And then we are we are moving into the window glass. So this window glass will be reflect or refer to the window glass that are um, that face to the outdoor. So now we are put the calculation or the items here, because we have two window on the west side, and then we have the south side, we have about 4 window here, so we will put in here. So now the first one will be the west window, which is the um, 1.6 meter times 2.5, and then we have to times 2, because they have 2 on that west side, and then on the south side we have the um, 1.6 times 2.5, and then we have to times into for quantity of the window there. And then next one will be the partition. So please be in mind the partition that we have here. We have on the east side, and then we have one more in the north side. So now the partition, we try to put into the E first. So E will be 7.5 times 3 for the area of this side of the wall. And then we have here is north is equal to, so now we are moving here, wall here. So now the wall here, they have about 18 times 3 meter on the all area of the wall. But please, in this area they have about door and window here. So now we have to minus on the window and door here. So now we calculate the door first. The door is about 1.2 times 2 meter, and then we have to times 2 because they have two quantity of door here, and then we have to minus again with the window here. The reason why I minus this one, I'll be explain later. So now 1.2 times 2 times 2, and then we goes into the window. We have 1.5 window times 3 meter window, and then we have to times 2 because they have about two quantity here. So now the partition here, as you can see, we're moving into the window and door on the north area. So because we have already minus that in that particular of the partition here, so now we calculate into wall with door only. For example, 1.2 times 2 times 2, and then this is for door. So I just put here door here, and then now window here is equal to 1.5 times 3 times 2 window here. Now on the ceiling, refer back the item that we have, the ceiling here, how much of size of the ceiling will be referred here. It is 18 times 7.5 meter. So just put 18 times 7.5 area of the ceiling, and then we have floor also is about 18 times 7.5. It is the same for the area of this particular specific of the office. So now let's begin with the calculation of area and then coefficient of B, and then the next one. So the first one will be the wall that faces to the outdoor. So that's why I like to put W west here, because we want to look it easy for us. For example, so now wall face to the outdoor for the building is referring to the west. So the west area of the building. So the specification of building here is, it is outside wall is medium construction. So let's look into the medium construction, and then the west the west for the coefficient of B here for the west is medium construction, and then it is west. So we'll be put the value here 56 because it is on the west side, and then it is a medium construction, referring to the building construction specification here. Outside wall is medium construction. So now put the value here 56, and then the area here is 7.5 times 3 is 7.5 times 3 is 22.5. 22.5. Please have calculator with you guys there, and then we have to minus it to 1.6 because of the window there, right? So 1.5 times 1.6, 1.6 times 2.5, and then we have multiplied to 2 because they have about 2, so it is get 8. So 22.5 we have to minus with 8, then we got about 14.5 here. So because since I separate into several parts, so after you put the value here, and then we can directly just drag here, then we know how much is the value there. Then the next one is refer to the south. South is here 34. 34 is here, and then here will be 18 times 3 is 54, and then we have to minus with what is 6 times 2.5, and then we have multiplied with 4, then we got 16. So 54 minus 16 is 38. So the area only for that wall that faces to the outdoor on the south is 38 meter square. And then next one will be the west for the window glass. The area first is about 1.6 times 2.5 equal to 4 times 2 is about 8 here, and then the south one is same like this one, is about 16. And then the partition for this area is about 7.5 times 3, so it is 22.5. So now here a little bit more complex here. 18 times 3 is equal to 54. We have to minus 1.2 times 2 times 2 is equal to 4.8, and then the next another one 1.5 times 3 times 2 is equal to 9. So 54 previous one is minus with 4.8 minus with 9, so we got the value here is about 40.2 meters square. And then the door here previously we got about 4.8, right? 1.2 times 2 times 2, it is 4.8. And then for the window we got is 9 here because it is the value here 1.5 times 3 times 2 here 1.5 times 3 is 4.5 times 2 is about 9. And then the next one is ceiling 18 times 7.5. So we got the area for the ceiling and the floor is 135 meters square here. So let's go with the coefficient. So I repeat one more time, the wall face to the outdoor is referred to the specification of the building. So the specification of building that for the wall is referring here, for the wall is medium construction. So refer to the medium construction here and refer to the coordination orientation of the wall or the window glass that we have no before. It is west, so it is medium construction, and then the orientation is west 56 here, so we put 56. And then the south is medium construction, south is we put here 34. And then the window glass here Then we go to the table of window glass here. So roof, since it doesn't have roof because it is in second floor, so it is a 5-story building. So window glass here, refer back to the specification of building. It is normal 6 mm thickness with blind. So goes into the window glass here. It is we have the blind here. So it is normal 6 mm thickness. So is it shady window? No, because if it is shady window, it is already stated in the specification of the building. So now it is normal glass plate. And then with blind we'll be using the coefficient here with blind. So now we go into the coefficient of B. First, it is normal glass 6 mm thickness, so the orientation is west, normal 6 mm west, so the value here is 650, and then we have to look into the south orientation, normal glass thickness. The sunny window coefficient of B is 290 here. And then next one is the partition. So yeah, don't forget the coefficient of blind here. uh, Next one is the coefficient of blind here. It is have the blind ventilation blind attached to the inside of the window, so the coefficient that we have to put is here 0.7. So in case of they have stated they have a drawing curtain, we can put either it is 0.8 to 0.7. So now the coefficient here we put 0.7 because it is have blind, so this one also 0.7 here. The other one for coefficient F is already put there because the first one uh, I've already mentioned before, we will be using the coefficient of 1. In case of it is residential, we can use 0.7 because it is not more, it is not higher compared to the industrial building like this one is office. So now look into the penetration of line is 0.7. So now the coefficient B for the partition, we already know the area here. So now for the east side, they doesn't bother either it is an east north, but I just like to put there because we want to know the orientation there. So now the coefficient B that we should put here, for example, is for the partition. So we already, this one is for the wall, so for the wall we'll be using the others coefficient, and then for the door and window we have to use the coefficient B of glass or wooden plate because the heat transmit into the door and window much more higher compared to the others that we are using brick, for example. So now here will be put it for the wall, then here also wall, then the door is glass or wooden plate, so the door will usually will be using material of wooden plate, wooden, so it is 13. So now window also usually will be used glass, it is also 13. So the partition here will be reflect, let me go through again for the, this is what we call the partition. Either it is have window or door, here, as long it is not facing to the outdoor, so we have to calculate or assume it is on the partition side because the heat all usually transmit on the outdoor area. So the outdoor area for window glass here is we are putting the window glass here, and then the wall also we put the coefficient here. So now let's go to the coefficient of the ceiling here. So we have complete the partition side, and then we will go to the ceiling and floor here. So what is the specification of the ceiling and floor? The floor is concrete with linoleum, and then the ceiling is only concrete. So now for the floor, it is ceiling and floor we are using only concrete. only concrete for the um, ceiling, and then the floor is with linoleum. So now for the ceiling is only concrete, so the coefficient of B here is 10. So the floor is have linoleum on the floor, so we will using the coefficient of B, which is 7 here. So the invasion of outdoor unit here, what is the volume of room volume that we have? We have calculated before. It is 405 meter cube. So we can put here 405. So the coefficient of B that we have here, either we want to use standard or this side. So usually, is it many entrance are in the room? Yes, of course, because we have about 2 door here, right? And then we have 2 door there. 2 or more wall face to the outdoor. Yes, also because it is 2 wall that face to the outdoor on the west side and then the south side. And then the coefficient of B will be 8. You can choose either 1.5 to 2. It is not wrong because it is only the estimation. So 8 times 1.5. I put the minimum one, 1.5. 8 times 1.5 is equal to 12. So now let's go to the person. How much people there? It is about person is 15. So the number of person there is 15. So how much the coefficient that we should take? The person is 15 and working only. So the area question for an outdoor is, we are using the standard, which is 1 invention of outdoor unit. The occupancy there is office working, right? It is office area. So the coefficient of B we should take is about 120. So you can choose also sitting on the chair. For example, it is classroom. For example, classroom application, we can select the coefficient of B is sitting on the chair. So but if it maybe it is in the area of manufacturing, for example, they are using some sort of physical working for a factory, so you can choose 200 for the coefficient. Much more higher will be reflect to the much more cooling load that we get. So next one will be the electric light. The specification of building, the light is fluorescent light. So we have to use the fluorescent light. 40 watts times 20, already stated 800 watt. So 800 watt is equal to 0.8 kilowatt. Directly times 1000. The area or coefficient of here is already constant. They are given by Ashri, so we just follow the calculation coefficient of B here. And then the electric apparatus doesn't state any electrical apparatus that are there. So in case of maybe they have computer in next exercise, so you just put the electrical apparatus here, so it doesn't have gas and LPG here. So that's why I like to use Excel, because we can easily get the data here. So for example, C is equal to A times B. You have to put the equal sign here. So select here and then sign times B. It is equal to 1812. So you just drag until below, because we already know the area there. Okay, and then the load that we should measure is equal to Q is equal to F, which is the correction here, times C, which is here. So we have to do it one more time, equal to here times C here. So this one, so now this it is not calculate equal to here times this one C. So now it's same, this one times this one, then this one will be this one times C here. So now it's equal to this one times, we try to drag it, can we get the data? So the formula is not there, you can, yes, this one. So you try to drag it until here, so at least you can get the data here. Please check the formula, so just drag it here. What time we do it here. I don't know why. Times here. So this one also same here times here. So that one equal to 1 times here. This one also same here times 945. Then the error coefficient is 1 is equal to this one times this one. So you want to get times symbol is shift 8. Shift 8, you can got the multiple sign here. And then here also same this side times 1800 is, it is C coefficient, right? So here is, we doesn't have the electrical light here, and then the fluorescent here we have 1 times 800 here. Then we have doesn't have electrical apparatus or any other things. So when we want to summarize how much the cooling load that we have, we just put equal sign here, and then we have to find sum. Double click it using Microsoft Excel version. We want to sum all the data here. So we already got the cooling kilocalorie 19428, or if you doesn't want to calculate it, you just put sign equal sign here. So it is automatic directly. If you have any changes here, you add one anything, because we are using the formula, so we can get how much the cooling load in kilocalorie per hour. So now if you want to calculate it, the formula here, we have already stated in formula here. If you want to convert 1948 kilocalorie per hour to BTU per hour, you have to times into 3.968. so you can use sign equal to here, and then you will times into 3.968, and then how much you get is 77,000. So 77,090.3 BTU per hour. So this is the estimation of load, 77,000 BTU per hour for this area of the office here. So that's all for the cooling load form. We will continue to the next lecture on the next exercise, but somehow this is example for you guys to know how we want to use the cooling load form. So please bear in mind that you need to have the cooling load form, and then you have to use the formula and appendix that I previously mentioned, which is on the page 8, 9, 10, and 11, to find each and every single coefficient of b, and then all the area we have to find it again. So until next time, see you guys soon. Any problem, you just text me or call me, and we can do a web conferencing on this particular Kulinok form. I know it is quite complex and complicated, but somehow usually it will appear in your midterm or final exam for this Kulinok form estimation. So till next time, thank you very much. Assalamualaikum.